Hello, greetings to all. This is from All-in-One Super Coaching. Let us move on with the chemistry lessons, the basic lessons for the preparation of the 9th and 10th examinations. We have already discussed about matter. From the matter, you have to consider the pure substances. And in the pure substances also, we have two types. One is element and another is compound. The smallest particle of an element which shows the complete property of that element is called atom. And the smallest particle of a compound which shows all the properties of that compound is called molecule. Here you might have noticed an additional information given when I defined atom and molecule. The reason is that initially at the time of Dalton's time, it was believed that atoms cannot be divided. But all of us know that atoms can be divided. When it is divided, all the substance will be the same, containing the same electron, proton and neutron, or some other subatomic particles also. So when we define atom, the smallest particle which shows all the properties make it complete. Okay. Anyway, let us consider the molecule. The molecule is also a combination of atoms. So by chemical methods, you can split those molecules as well. What is the result? The result is that finally we end up with the collection of atoms. So in chemical reactions, that is our point of interest, because we are going to study the chemical reactions, then only our difficult situation appear, right? So finally we have to consider atoms. So let us redefine like this. Atoms are the smallest particle of elements which take part in chemical reactions. As we know, there are around 105 elements approximately. We cannot be sure because the last stages of elements are radioactive. We are not sure whether there is more or less or anything like that. And that number is not fixed. That can vary. And we are not sure because there are many radioactive substances in that. Now let us simply understand what is the law of constant proportion. It is nothing. It says that when a compound is formed, there will be a mathematical proportion, a constant proportion everywhere in the universe. For example, water is the combination of hydrogen and oxygen. The formula is H2O, that is 2 hydrogen and 1 oxygen. That means the mathematical proportion is 2:1. If you go to anywhere in the universe, in the galaxy, H2O will be the same, that proportion will be the same. Next is carbon dioxide, that is 1 carbon is joined with 2 oxygen, the proportion is 1:2. Anywhere, everywhere, it will be like this. Let us take the case of ammonia, NH3. It is a 1:3. This is the only meaning of a law of constant proportion. But in the textbook, when we read, there is a long sentence, you will never understand what they mean. Okay? Then, in this way, we have to try to understand, comprehend it, instead of just reproducing the same sentences without meaning. Then, let us pass on a little on the symbols of the elements. You know, it is difficult when we are going to write the chemical equations, it's difficult to write the full names of the elements, okay? And also we can find all the symbols of the elements available in the periodic table, and the rule is that the first letter should be capital and the second letter should be small. One more difficulty in that, most of those names of elements are not English. Many of them have come from Greek, Latin, German, that type of languages. For example, iron, actually it is IRON. If we had to write in English, it should have been I, capital I and small r. But it is FE. Why? Because the Latin name is ferrum. That is the reason for. There are many like that. We only don't want to think more over that. Just study the symbol, and we should know which symbol represents which element. Then the next important part is, and really this is very important for our forward movement, the differences between ions and atoms. Here we have to mention the structure of atom. Even though we are going to study it in detail, initially we have to understand that there are three types of subatomic particles in an atom. One is neutron, another is proton, and next is electron. And out of these three, neutron doesn't have any charge. Proton has one positive charge. Electron has one negative charge. So, and also in any atom, the number of protons will be equal to number of electrons. That is, if there are 4 protons, there will be 4 plus charges, and equally there will be 4 electrons, that is 4 negative charges. Both of these, by the mathematical principle, cancels each other, and the ultimate charge on the atom is 0. Then what is ion? Ion is the same atom only. Only that the proton and neutron will never leave the atom because they are in the nucleus. You cannot take it out. It will always stay there. But the electrons can move from one atom to another atom, or from another atom to this atom, electrons can enter. In this condition, what happens? The number of protons and number of electrons vary. If electrons are coming into the atom, the negative charges will be more than that of the positive charges. Therefore, that atom becomes negatively charged. That negatively charged atom is called a negative ion. In the same way, sometimes the atom may throw away or lose electrons to take part in the chemical reactions. In that case, what happens? The number of electrons are now less. The number of protons are more. Ultimately, what happens? It will become positively charged. So, in that case, when the atoms are losing electrons, it will become a positively charged ion. So, it's very clear. It's only the same atom. An atom, when either they receive or lose electrons, they become electrically charged. Then they are called ions. The mass of ions and mass of atoms will be the same because electrons are considered to be having nearly zero mass.